Morning, everybody. So, one thing I was going to mention in this video, I forgot. I had some complaints from the shake, rattle, roll. Somebody told me I needed to turn stabilization on in my camera in the last video. And you're right. I'm not arguing with that. These are wobbly, shaky. I have some funny handshakes. I don't think you probably see much of it now, but I'm not very steady. That's why if you see me welding, you'll never see me out there just one hand out welding. It's because I'm always propped up against stuff, leaned against. And you'll see, like, my weld beads aren't as pretty as a lot of other people's because of that. But anyways, so long and short of it is I'm using an old cell phone. Like, literally one of my castaway cell phones is my recording device for doing this. I just ordered a GoPro Hero 11 Black that's supposed to get delivered today. So I'm going to be curious to see if that fixes all the problems, because it's supposed to have all kinds of crazy stabilization built in. But anyhow, so I'm not ignoring all of your complaints. I just haven't had a good fix. And just in case anybody was curious, by the way, so I got this YouTube channel cruising along. The last video just exploded. I don't know who all of you are that want to watch some crazy nut screw around with old excavators and equipment, but thanks for watching. But like 30-some thousand people have viewed that video. That's the biggest number of watchers that has ever happened on one of my videos. And I think that one, they just monetized me like 3 months ago. I think we made 50 or 60 bucks on that. Okay, like since I monetized, or my channel got monetized 3 months ago, we've made a grand total of $247 off from YouTube before taxes, and then they take taxes out. So I just letting you know that, like, you don't get rich off from YouTube. You don't do this for the money. I mean, maybe you get to 50 million subscribers. Okay, they're making all kinds of money, but doing the stuff I'm doing it for the fun of it. And like the camera I bought cost way more than the amount of money that I made off YouTube. I just decided, and this is what I'm going to do going forward, is I'm making my living doing this stuff. It has nothing to do with the YouTube videos. And so if money comes in from YouTube, I'm going to keep spending it on better gear. That's what I've decided. Like, we're just dumping it back in. So as money comes in, you'll probably start seeing an improvement in quality if you guys keep watching, just because I'm going to start buying better gear. But that said, we have welded the faces up. It's kind of tricky because I'm running 16th inch dual sealed wire, Lincoln 71 Elite, and it's a little bit much for this size. Like, I'm having to be careful or I'm like blowing off the edges, but that's why it's as lumpy as this. I had this laying on its side, welded both faces up because on these little minis, these are in line with each other, those faces, and both outside faces here at the bucket were just smoked. So I've welded the faces up, and then I had it sitting the other way up, and I've welded all the way around that side. Now I've flipped it over and I'm getting ready to build up in here. And then the next step is going to be to clean off the boring mill because I've been out of the shop working. You see there's still set up from when I did that modifying the facing head trick because I needed it bad for that job, so I just did it and ran out of the shop and didn't clean up. So I got to clean up, and then we'll get this baby set up on there and do some hole boring. So I'll bring you back. I got something to show. I have not been showing you any of the welding because even if it was worthwhile watching, you can't see what I'm doing. When I'm in a hole that size, I can hardly see what I'm doing. I actually really dislike tiny ones like this. They are such a pain in the butt. Two things, welding in it, and then this simple boring head arrangement that, you know, mimics my portable line boring setup is what I actually like the best for hole boring. It's super rigid, but the finished diameter of my holes over there is some metric dimension that's, I haven't even figured out what it is, but it's about 2 inches. That thing's 2 1/4. So I'm going to be screwing around. Oh, let's see here. I'm going to be in there with some rinky-dink boring head. I don't even know where I went with it. I'm going to have to dig around, but anyhow, what happens is you got to go in there with a much smaller boring bar, and then you get more chatter and more deflection, and it's a pain in the butt. So, oh yeah, like I'll probably have to set that one up is what I'll have to do, and it's just a nuisance. So my favorite is about a 3 to 4 inch hole. They're big enough you can see what you're doing. Bore weld them, like this is so small you can't even run, maybe a good bore welder would fit in that hole with some adapters, but mine, you can't even go in a hole that size. You can't get it to work in there. So anyhow, I'll bring you guys back when I got something else worth showing. All right, everybody, here's where we're at. We're sitting on two identical stacks here, so I'm just taking on faith that that has me as good as I can be this direction. And then we screwed around back and forth, indicator here, an indicator here. It's really tricky to get that darn in there. A lot of monkeying around. But anyways, right now I'm within 1/1000ths across there, and I finally gave up. What's going on is when I would thump it around, because this is all kind of a wedge, it's trying to spit the whole thing out that way as I shifted around, and I was overshooting my number. I finally thought, okay, this is ridiculous. 1/1000ths is less than the clearance built into these bushings by a long ways between the bushing pin. I need to just stop. So anyways, once I had that set, came in and tacked this homespun angle plate right to the end of it, and then tacked that one over there. Mostly because of this taper, I don't trust this thing to not try and walk down here if we get vibration. So what we're setting up for now is I want to go ahead and cut this face off square to start with. Bummer, it didn't fill in all the way on my weld. I got a low spot, yeah. So I think...
my arms are getting tired.
Alright, set her down. Alright, everybody. We are back at this project. So, I have been shooting video with the new GoPro Hero 11. It's been a disaster. I'm having holy fits processing the video. Even after I dumbed it down, I can do it now, but it's slow. So we're back running the old cell phone recording system today because I've already lost so much footage of cool stuff that I'm disgusted. So we'll get it figured out, but we're gonna do it slower pace. So that's why there's been the big hole in videos all of a sudden. So I think I have some video of the rest of this project that didn't get shot with the GoPro, and I'll add that into here. But so anyway, we're up to now. This bore is the one that this thumb pin's onto, and it had these two bushings rattling around in there. Shop pin. They wanted, what was it now? Almost $700 for that pin and those two bushings. It was absurd. And the real problem here is the bushings aren't actually what wore out. This is so thin that it's stretched. I mean, excavator thumbs are subjected to huge forces. Tube that it's in's thin, the strap around it's too thin, so the problem is even if I fix it, it's not permanent. So we're gonna do something that's a little hillbilly, but is the best compromise I can come up with here, and that is I'm gonna machine a solid, just mild steel bushing that goes in there, and then we're gonna weld it in. Now, if they keep it greased, a thumb doesn't get flexed very much. You mostly set it in one position and use it that way. It'll probably last another 4,000 hours, and we'll just have to cut it out when we do it again. And then I'm making them a pin out of 4140 pre-hard. So that's what we're getting ready to do, is make the bushing that's going in there and make the pin. So I'll show you the guys that process. Alright, so I'm about to do some serious hillbilly machining, guys. I'm going to show you a trick. Maybe you already know it, maybe you don't. I'm just warning all you apprentices out there right now. Don't blame me when you use this trick and your boss gets mad at you. It's not high precision, it's high speed. So I need to put a through hole in this pin 5/8 of an inch in from the end. So I've set it up, probably hard to see in the camera angle, but I blued up a spot, scribed the line 5/8 from the end. So I'm going to take a tap, it's got a ground point on it, and I'm going to put it in my drill chuck. And we're going to get positioned, lined up on that line. Now, take out your 6-inch pocket rule. Take your pocket clip off. It's going to be hard for you guys to tell exactly what I'm talking about from your angle, but you'll have to take my word for it. This darned radial drill is not actually leveled completely, so it's wanting to swing off to the side on its own. Now, clamp that baby, and you can swivel back and forth, and when you're dead centered up on the bar, your pocket scale will be level with the face of your chuck. Looking good. Verify that I'm still on line with my... Oh yeah. So you need something with a accurate point on it. That's why I like to use a tap, because they're all ground. I've done some checking. This will get you, I'd say, pretty consistently within 10 thousandths. And in this instance, that is more than sufficient accuracy. This is just a retaining bolt hole for a pin on a piece of heavy equipment. So yes, I could set it up in the mill and get all centered up on it. But two things, I've got a job in the mill right now, so it's tied up, and it'd take more time. And once again, you've always got to be asking, like, how does the price fit with what the customer is actually willing to pay for what they're asking me to do? Oh yeah, I forgot, it was a major slow speed last time. I got that bushing slapped in there. And now I got to tack it and then probably have to hone it or ream it after that because it's already shrunk it down. I think I coined the edges over. I had aluminum block beaten on it, but even doing that, you'll displace metal. So anyways, I'm going to get this thing tacked in place. I say tacked. I'm going to weld it in pretty good actually. So the entire point of this is basically the base material is too thin and it's stretching. I'm basically combining the strength of the bushing with the strength of the existing sleeve. Those two together right now are only half-inch thick, which when you consider the kind of loads this is subjected to is absolutely ridiculous. Like, frankly, work brow fell flat on their face for this one. Like, I don't even need an engineering degree and a bunch of fancy CAD programs to tell me that that was a really, really stupid design. But anyways, I guess stupid designs like that are what keep guys like me in business. But anyway, we're going to flip this thing over. I'm going to take this out before I dump it on the floor. Weld the other side, and then it's going to be time to get that finished sized, and then it's just a matter of reassembling all this stuff I've got apart on this arm because it's ready to roll then.
Are you recording?
Yep. So this thing is shrunk down in the center. This was bell mouthed at the edges and was still small in the middle, and I intentionally left my bushing quite tight because I wanted it to line up good before I welded the edges. So anyways, my hillbilly fix for that, I could go in there and flap wheel in the middle, but I happen to have an 1.5-inch reamer. And it's a Morris taper shank reamer, but it's shell reamer, so I'm going to try spinning it by its retaining nut. It ain't working, it's driving it off there. Okay, we're going to have to try turning the tang. I didn't want to because it's easy to twist these tangs off. But I'm hoping, if all my math is right, that I'm actually only shaving a few thousandths out of here and I'm not going to have to put that much load on it. Yeah, it's dropping through there pretty nice. Shot of the old lube. Yeah, she did take some nice little shavings out of there, so let's see. That made the pin like going through there better. Or it would go in from each end and stop in the middle. Hey, look at that. Perfect. That's exactly what we wanted. The pin is about 2 thou undersize, and that reamer was an on-size reamer, so that is awesome. So all we got to do now is get this grease fitting out of here, chase the grease hole on through, and then we're ready to put Humpty Dumpty together again and get one more project kicked out of my shop. Well, everybody, this one is done. There wasn't a lot else that needed showing. I just was assembling. So just for a frame of reference, let's see here. I got to think here. What did this job end up costing? I've decided we're going to start trying to post more of that. To be perfectly honest with you all, there is way too much bullcrap floating around on the internet about we could have done it for that much or this much. The best way to stop that kind of craziness is start listing some real prices. So here's the interesting thing. The dealer sold me that pin, and 4 bushings, and the side spacers and a couple of seals, and that was $973 from the John Deere dealer. The only reason I did that is because we needed to get this job on the road and get rolling, and I had to have those parts for dimensions. The John Deere dealer, for this pair of pins, the side links, that, and a couple other parts, was $2,600. Like just the H-link, they wanted, what was that? Darn near $1,000 just for the H-link. And it is a flimsy, wimpy thing that's all skeletonized in here. That's where it breaks, actually, is right through there because it's got a big skeleton hole in it there. So anyways, I ended up getting these all from a company out of the UK. What is that? J. Reed and Evans or something like that. They've got a U.S. warehouse, so it took them a week to get me the parts, but they got them here. Anyways, the pins, the links, those side links, and that. On these side links, John Deere dealer was, what, $300 a piece. Aftermarket was $188 for the pair of them. So anyways, it ended up being, grand total was under $700 for all these parts, aftermarket, and it would have been $2,600 from the dealer. So no brainer there. So the fixing the stick end, it's a little bit more complicated there. Is this one between, I had to go parts running and parts chasing. I do not mark up parts, by the way. That's been my policy ever since I got in business. I do not mark up parts. I charge time to go collect them, track them down. I feel like that's a very straightforward way. People know exactly what they're paying for, right? Like they're getting this many hours of work and they're paying this much for the parts. They don't have to question it. If they ask, it's just, I'll show them any of the receipts. There's no markup. So anyways, when I give you my time, you got to understand it's not just boring and machining time. It is also tear down. Like this, they brought it to me just covered in grease. It's still a friggin' mess, even after I spent a whole bunch of time power washing. But at any rate, I had to disassemble it, deal with goop and grease, power wash it, chase parts. So by the time I got the stick end done, I had 15 hours in it. I'm billing $120 an hour for shop time. So we had $1,800 basically in parts acquisition, cleaning, disassembling, and getting that part done. Then the pin and bushings in there, dealer was over $600. I ended up buying material that's $41.40 pre-hard for the pin, and then just some DOM tubing for the bushing. $125 for the material, and then the machining and installation time was 3 hours at $120 for $360. So that they ended up with, let's see here, $485 in the parts and the repair. Just the parts would cost more than that if you got it from the dealer. And like I mentioned in the video earlier, the engineering is so bad that it would die immediately again. So anyways, all of that to say, the grand total on this fix, parts and labor, is $3,895. So just in case anybody out there is wondering, that's the kind of money that, like if somebody just brought me the stick, or if I went to their spot and fixed it, I didn't have to tear stuff apart. I didn't have to deal with totally destroyed, as this was major wiped out. It was just a normal loose bushing. I would expect to do a stick end like this in, I think the last one I did had $800 in it or something, like mileage, everything. I think I was at like $800. So when you see the $1,800, that starts to give you a little bit of frame of reference for why, unless you are making a lot of money, it really does pay to tear your stuff apart, clean it up, and have it ready to go for the boring guy before he gets there. I'm willing to do all that, but I got to charge for my time. So anyways, and you can't blame it all on that because, like I said, that one was exceptionally destroyed. It'd have probably been a $1,200 stick end even without that. 'Cause I had tons of face buildup to do, bore buildup. It was a lot of screwing around, and the hole was so shot, it was way out of position. I had to move it back to where it belonged. So it was probably a $1,200, maybe even a $1,500 stick end just as a result of how bad it had been let go. But anyways, so there you have it, guys. That's the wrap on that one. They're going to get her out of here in the morning.